Hey everyone, and welcome to the first episode of the Ecosystem Spotlight series. My name is Patrick. I'm the Ecosystem Growth Manager at Oasis. And today with me, we have Dani Villardel, who is the PhD student at Cornell Tech. He's also working closely with Professor Ari Jules. And we also have William, who is the head of Ecosystem and my colleague at Oasis. So the goal of the series is to showcase what the partners are working on. And there's no better way to kick things off than with a project that got just recently introduced and is already challenging the way we perceive wallet ownership. I'm talking about the liquefaction concept and the Take My Ape project. So without further ado, let me hand it over to William and Dani so that we can dive straight into the topic. Will, take us away.
Oh, awesome. Thank you, Patrick. And hey, Danny. Nice to have you on again. I guess the best place to start is we can get into Take My Ape in a little bit, but maybe we can start with overall, what is your recent research on liquefaction done? And what is liquefaction?
Yeah. Well, first of all, thank you for having me here. I'm really happy to kind of be able to showcase our work at Cornell to such a nice audience. But basically, the concept of liquefaction, what it does, it takes the fact that private keys are only used for signatures. And when it comes to interacting with the apps in the blockchain space, the only useful things are the actual signatures and not the private key itself. So liquefaction kind of takes this basic idea and makes it so you can kind of have ownership of the signatures, but not the private key itself, allowing to kind of split up the message space of signatures and maybe allow someone to sign messages that relate to DAO tokens, someone else to sign messages that relate to NFTs, but both with the same private key. That's a really basic idea, and we'll see later that it's a very powerful idea.
Yeah, absolutely. I mean, I think even at Oasis, we were impressed with the original paper on liquefaction, but day by day we think about more and more use cases, and I'm sure you do as well. That's this is the subject of your research. Maybe we could just go into, I guess, on a more architectural level, or actually no. Maybe we can just talk about that, what the Take My Ape demo is. From my perspective, it's the first example or first demo which uses liquefaction. So it's the first demonstration of liquefaction, let's say in a productive way, and sort of inspires or takes it out of the abstract idea, and you can see it concretely for what it is. So maybe you can go over what the Take My Ape demo is, and then what the architecture is behind that demo.
Yeah, the Take My Ape demo is kind of a project we worked on to showcase the liquefaction in a specific use case. But first, let me quickly introduce what's the single entity address ownership assumption, which is kind of a key concept that we are breaking in liquefaction. I think it's going to make it easier to later understand what Take My Ape is. Basically, in blockchain settings, what people kind of assume is that the person that owns the address also owns the key. It kind of makes sense, because if you shared the key with someone and two people had the key, one of the other person could just steal the funds from you. So it makes no sense to assume that two people own the same address. That assumption can be seen in many places. There's the soulbound tokens, which are supposed to be tokens that can only be owned by a person. They are soulbound. Or even airdrop rights are supposed to go to the person that actually did the work on the project or was meant to receive it. And even in NFT scenarios where you could have some event that's token locked that can only access by people that own a Bored Ape, for example. So we in the liquefaction project show that by kind of splitting the message space, as I mentioned in the before, you can kind of share ownership of assets in your account with other people without kind of worrying that they will steal the asset from you. that's showcased in the Take My Ape demo, where we kind of send an actual Bored Ape to your account, and you can do anything with that Bored Ape. You can log into a website that's kind of locked to only Bored Ape holders. You can enter the metaverse. You can even sign messages with the account on Etherscan that say, I own the Bored Ape. The only thing you cannot do is steal the Bored Ape, which means transfer the Bored Ape to another account. And that's kind of crazy when you think about it, because from kind of like an account holder perspective, you don't lose any capabilities on the account. The only capability you lose is signing a transfer message of that specific Bored Ape. And we finished that project about a month ago, and it's now released. You can check it out in takemyape.com. There's a walkthrough video, and you can play with it. And something pretty cool is actually that there was a video game called The Other Side. They did kind of 2 big events back then, but they did not have kind of an ongoing live server where you could connect to. And 2 days ago, they announced that they would launch a server you can connect only if you have a Bored Ape. So you will be able to play that video game, and just for the cost of like an Ethereum transaction, that could be less than $1.
Yeah, that's very cool. Yeah, so you didn't even know that before you were, I guess, creating this demo, that they would be having this release. So anyone who wants to, I guess, demo the game for 10, 15 minutes for $1 or something like that, they can do that. Or, I think even if they get lucky, if no one else tries to rent it out, you can have it for up to like a couple days. So that's really interesting. I already played around with it, but maybe I'll have to get another Bored Ape and try that out too. In terms of liquefaction, I guess I just wanted to maybe give like a, my own sort of way I have a mental model of it. And it's really just like a very fine-grained access controls for what you can do with your wallet. I remember one of the, I guess the coolest things is like, you could like grant someone else permission to vote in a DAO with with your governance tokens, and then you could like grant someone else, I guess, permission. I don't know why you would do this, but like to stake those same governance tokens. Like you can really say like each individual type of signature or each individual action that you can do with the wallet has its own access policy, which I think is just like really cool. And when you think about like what we need with Web3, I think that is going to come, like, it's going to push the industry a lot further, a lot faster. Although I do get somewhat concerned if you do create wallets using this. We already have problems with people blind signing. I don't know. It might be a little bit too over the head, so we have to maybe abstract that away a bit. Cool. I guess, so you went over this Take My Ape demo. What are some, I guess, other use cases for liquefaction that you find interesting, or that maybe, are up next for you or anyone else in your lab?
Yeah, you phrased it really well. It's actually just a way to kind of allow to put logic on top of addresses in form of access control policies. So you could have control policies to access the messages to vote in a DAO. You could have access control policies to kind of be able to transfer some specific amount of balance from the account. So some of the cool use cases, we came up with a lot of use cases. You can check them all in our paper. There's a big list with maybe 30 different use cases of liquefaction. The one of the biggest ones is actually the one that kickstarted the project. It was back then in 2018 that Phil Dayan, a former member of our lab with Arijules, also the founder of Flashbots, wrote a blog post on dark DAOs. Dark DAOs are basically a form of privately selling your DAO tokens for specific proposals. That's pretty cool because it allows you to sell your votes for each individual proposal separately. So you don't have to kind of sell out your whole tokens and then have to get them back at another point. The other interesting thing is that the fact that it happens privately. So that's idea was built on top of the same construction we use for liquefaction. Liquefaction actually generalizes this idea. And by this generalization, we were able to also, for instance, sell airdrop rights, or even, that's a pretty interesting one. It has some backstory. Have you heard about Constitution DAO?
I have, just because we talked in the past, but maybe, you could give an overview for the rest of the listeners.
Yeah. Well, Constitution DAO was like a DAO that was meant to, that was created to buy a Constitution of the United States of America. It was in an auction, and they kind of raised funds, and they were outbid, but by a really small amount. The reason they were outbid is because their bidding was public, while the actual auction was private. So if there had been a way for them to do the auction privately, they would have been able to kind of win the actual Constitution. Our liquefaction allows for this kind of private bidding. And a point I want to make, because I think it's quite important, is that liquefaction works in any blockchain. It works in Bitcoin, it works in Ethereum, it works in Solana, in XRP. And the cool thing is that it does not require the actual blockchain to have smart contract capabilities. So by kind of allowing people to add logic on top of addresses on any blockchain, you're actually enabling addresses to be smart contracts on their own. So you can have Bitcoin have, for instance, smart contracts by kind of using the addresses as smart contracts. That's like one of my favorite use cases, actually. Yeah, go ahead.
Oh, no. I was going to say, I mean, I think it's interesting. Yeah, the Constitution DAO, I guess, auction is sort of like a real world NEV, right? Like it's like the blockchain and the real world have trouble communicating. But with liquefaction, everything occurs off chain. And I know this might get a little bit technical, but can maybe you go into the role Oasis and TEs play in liquefaction? Like how are we creating these encumbered wallets with these access patterns? What's actually happening on the back end?
Yeah,
was the privacy, I guess, maintained that you mentioned?
Yeah, that's a good question. I think we can get technical. I think the basic concept is not too complex. The basic idea is all the blockchain accounts addresses are linked to a private key. And if that private key is hidden inside a TE, then no one can get signatures on top of it. But TEs allow to kind of code logic into them. And you can use the fact that you can code logic into them to have logic that restricts access to the signatures of the keys that are hidden in the TE. So that's the basic idea. You hide a private key inside a TE, and then you implement access control policies within the TE that restrict how people can get signatures from that private key. An example for that would be if you want to allow someone to sign voting transactions, you would kind of authenticate the person via their own address, and then kind of give them the signed transaction when they request it.
Right. And one of the key parts of that, though, is, and it's something that our team has learned, but is that the initial private key has to be generated within that TE as well, right? Like at no point can anyone have ever seen the private key. That's what really is, I guess, the driving factor of liquefaction, is that this wallet, which I guess you guys have named an encumbered wallet, exists in a black box, which that's what a TE is. It's a black box, a hardware black box, where no one can see inside. And therefore, no one can sort of maliciously try to sign transactions before the TE or before the access that go outside the access control. Is that correct?
Yeah,
Okay.
That's correct.
And so the TEs that you've chosen for liquefaction right now use Oasis, and I mean there are other alternatives, like you said. Philip Dion Flashbots, are quite the TE experts as well. there's Fala, there's Marlin, there's Secret Network. What made you guys choose Oasis? And maybe also, like, what are the benefits of using a TE that's connected to a blockchain network versus an off-chain TE that maybe more like Flashbots?
Yeah, that's actually a good question, because when you think about it, Liquefaction just needs TEs. It does not need the whole blockchain infrastructure, which kind of blows up the whole requirements. But there's many use cases of Liquefaction that actually require this kind of trust in the TE that you don't want to have. For instance, if you're kind of buying a vote from someone, you want that vote to come to you. So you want to, for instance, the person not to be able to kind of turn off the TE at any point and kind of get the assets and not give you the signatures. So by building on top of a TE blockchain, we ensure that people can both attest to what's happening and also ensure that it's actually going to happen, that no one's kind of going to unplug the computer and have the private key that's hidden in the black box disconnect from the world, like allowing people to steal funds, for instance. And as far as the choice, when it comes to choosing Oasis on top of other TE's infrastructure or TE blockchains, we chose that because it's pretty flexible in terms of how you use it. It works on, it's an EVM compatible chain. You can code in Solidity. There's many interactions between Ethereum and Oasis, so having everything in the same kind of language makes it much easier. And also the fact that there's like a really nice testing environment and deployment is quite similar to any other chain makes it really compelling to use.
And am I correct in saying that you had never really coded in Solidity before this demo? Like, you taught yourself Solidity in like the course of like a month and built the entire demo out?
Yeah. Actually, I have coded quite a lot, mainly like algorithmic programming and like programming competitions, but I had never kind of been in the blockchain space till about 7-8 months ago when I joined Cornell. And my coworker, the main author of Liquefaction, James, he's a great in the Web3 environment. He's a really good researcher, and he was really nice in teaching me how to code Solidity. So I got to learn quite fast.
Yeah, well, I would say that's definitely impressive, and I guess maybe that's why you're working with the best of the best with Ari and James over at Cornell. I kind of derailed myself by asking that question. I forget what I was going to ask next. I was going to say, I was just going to comment, you talked about the blockchain in terms of like you need it in order to make sure the blockchain is never turned off or anything like that. Is the like immutability and the I guess ability to like audit transactions and prior transactions, is that in any way relevant, or do you not really need that because you have remote attestations? And I guess for listeners, remote attestations, the way that I think about them, is like a hardware version of a ZK proof. So the ZK proof is like the cryptographic version of proving that something happened or the testing that something happened, and remote attestations are I guess the hardware version where the TE is communicating with the blockchain saying, yes, this computation was done. But I guess what I'm asking is that enough, or do you also need like the immutable ledger aspect of the blockchain?
Yeah, I feel it should be enough, the attestation. I mean, you still need this kind of immutability in the sense that you want that the code you're running, like that you are testing now, will be the one that you run maybe in 1 day or in 2 days. You don't want that to change. So that's kind of the reason you want immutability. But other than that, as long as you know what's running at what you kind of, I mean, you could require immutability in the sense that if you pay for a vote, you should be able to get that vote later on. So you don't want anything to change there. but it's the main purpose of using a blockchain is ensuring that the thing, like the computers don't stop running and people don't kind of run off with your funds. And that's more the liveness property of blockchain and not the immutability.
Right. Okay. That I was just trying to understand better for myself and maybe for the listeners as well. Okay. So we've gone over, I guess, what your current research has gotten to. One question I want to get to ask before we talk about your future research, though, is if there are Web3 developers or, let's say, cryptographic researchers or anything like that who want to start, playing around with liquefaction, maybe building applications using liquefaction, how can they do that? Where can they find, is there a central source of truth for this research or any tools available to them?
Yeah, as part of our paper, release paper, we built an artifact, which is basically a code base that implements a really modularized implementation of liquefaction that kind of splits up all the wallet or private key handling and policy creation in really small submodules, and allows you to kind of implement any liquefaction idea you have on top of that really easily. You just have to kind of care. You use the correct policies, but you don't need to kind of re-implement the whole wallet handling functionality. I'm actually now working on the implementation of another use case of liquefaction, which is the wrapped Bitcoin. As I mentioned before, liquefaction enables you to kind of add logic on top of blockchains that don't have smart contracts. And Bitcoin is one of them. And having wrapped Bitcoin be able to use smart contracts would be a really powerful kind of use case of liquefaction. And I'm kind of finding out how easy it is to implement on top of what we already have, what James and I built during the first part of writing the paper. And I'm really happy with the results. So I encourage anyone to kind of check out the repo. And warning, it's not audited. So I would make sure that it gets audited before, but it does kind of build the whole infrastructure pretty well.
Right. I mean, it's like, as you mentioned, it's modular. And it also, I guess it's just a great way to kick off, you're anyone who wants to build a liquefaction use case. You don't have to build everything from scratch, which I think is always the hardest part, right? It's like, thinking out in your head where to start, how to begin. I remember I sent the repo over to a few people and they said it was fairly organized, fairly easy to follow. So anyone who's involved in the research field or a Web3 developer who has a cool use case for liquefaction, check out that repo and we'll try to link it in the video. Actually, there is one other topic I wanted to talk about before we go into your future research. And that is, in your original paper, we talk about, some of the use cases. Some of them are adversarial, some of them are beneficial. But in terms of the adversarial use cases, what are, are there any methods that are known in order to combat these adversarial use cases?
That's a pretty funny story because it's a weird, usually in security research, people come up with an attack and after that, someone else comes up with a protection to that attack. But in our case, it was a bit the opposite. We came up with a defense to the attack and then we kind of published a liquefaction paper showcasing how many bad things you can do with this concept. So it's a weird thing that happened here. So it all comes down again to the 2018 blog post by Phil Dayan, where he showed that you can sell votes. So our group started thinking, how can you kind of avoid these, what we call key encumbrance? How can we ensure that the user actually knows the private key or that the private key is not hidden inside a TA? So they came up with a technique. It's kind of fight fire with fire that allows people to proof that they actually know the private key, or that the private key has at some point been outside of the T. We call that proof the proof of complete knowledge, because kind of showcases that you know the whole private key. And the construction is pretty simple. It's actually like providing an attestation of T that kind of output the non-encrypted public key. So you can kind of showcase that this public key was kind of spit out of a T non-encrypted at some point, and therefore kind of seeing the real world and being unencumbered.
Yeah, I mean that's a little hard. When you say you're showing that the public key, how are you proving that like the private key has been out of the T? Maybe like, is it just that you can sort of show that the private key results in that public key, or like what is being proved there?
Yeah, maybe I by mistake said public key instead of private key. I meant private key at all point. It's the T will kind of spit out the private key at some point. So by providing an attestation that the private key you're using to sign has also been spit out by the T, that kind of showcases that the private key has been outside of a T.
And that can be done privately, like you're not exposing your private key to the rest of the world, I'm assuming?
Yeah, that's a great question. That's what we thought at the beginning, because usually Ts are things that are owned by cloud computers, so you don't want to be sending your private key to a cloud computer. The thing is that phones, specifically Google phones, if I'm not mistaken, are starting to implement Ts within their own phone. And actually, James Oskin, my coworker last year, was able to implement this kind of complete knowledge proof generation on top of Android phones. So you are able to showcase that your key is not encumbered with your own phone and the private key not leaving your own phone.
Very cool. So yeah, like as you said, we had the solution. We had the solution for these attacks before you even sort of thought of all these different use cases, or I guess some of them adversarial use cases. But yeah, I guess shifting gears a bit, let's focus on a beneficial use case, one that you have just received a grant from Oasis. I'm pretty sure it's already signed. So I think you'll be working with us for the next 3 months to help build out this, and it'll also be part of your research. You want to sort of give a high-level overview of what you're doing with wrapBTC and why you think it's beneficial for Web3.
Yeah, it all comes down again to the fact that you're adding logic on top of addresses. As I have mentioned before, that can be used to add smart contracts on top of Bitcoin, as well as kind of have Bitcoin tracking in the T where the encumbrance happens. And that allows you to kind of wrap Bitcoin and use Bitcoin in Oasis network as if it was in the actual Bitcoin network. So that's a pretty cool thing, because it allows you for interactions between the rows, the native Oasis token, and Bitcoin as if they were in the same chain. And not only that, since we are doing that with Bitcoin and we are sending Bitcoin to Oasis, we could send any other token in any chain, because we don't require the chain to have smart contracts or any specific property. For instance, you could send ETH to Oasis, like wrapped ETH to Oasis, and you can have now interactions between wrapped Bitcoin and wrapped ETH in Oasis as if they were both in the same chain. This is different from L2s, as the tokens that, or the assets that you're encumbering or sending to Oasis wrapped, actually keep their properties in their original chain. So if you have an NFT in a specific chain, you wrap it and send it to Oasis, you can still use the NFT to log into websites. And or you could now buy NFTs with Bitcoin trustlessly. And the kind of cherry on top of that is that the interaction between encumbered accounts can be done without the need for bridging. There has been many attacks in bridges before. Before the ZK bridge paper, if I'm not mistaken, there were $4-5 billion stolen just by misuse or like bad implementation of bridging. So kind of removing the trust on bridging when having cross-blockchain interoperability would be a big deal. And that's what we are looking into now with my research group. We came up with a construction using liquefaction that enables different blockchains to interact without the need of bridging. And it all happens in Oasis, which is pretty cool.
That is very cool. And yeah, I guess I have now a lot of questions. But so the first question I have is, you talk about wrapped Bitcoin coming to Oasis and wrapped ETH coming to Oasis. This is very cool. But could you also bridge wrapped Bitcoin directly to Ethereum, or at least act as if it's already on like have it be represented as like an ERC20 token on Ethereum or something like that?
Actually, all the logic happens in Oasis. So when interacting between two chains, you need to do that in Oasis itself. You cannot send wrapped Bitcoin using liquefaction to Ethereum. The reason for that is that liquefaction needs encumbrance, and encumbrance needs TEs. So it can only happen within TE-based blockchains. So when I talk about cross-chain interaction, is any two chains interacting within the Oasis network, but their respective tokens are kind of jumping from address to address or kind of being used with different smart contracts on their respective chains. But all the logic, all the signing logic, all the kind of restriction or smart contract behavior you implement on top of those assets happens in Oasis itself.
Okay, so the logic happens on Oasis. But like, for example, would you be able to take Bitcoin on the Bitcoin network and then, like, let's say, use it for lending within Aave on Ethereum? Or no, that's not possible using this sort of idea?
Yeah, that's actually what we are looking into right now. We are looking into how you can have encumbered tokens interact with non-encumbered tokens. That means that if you have a smart contract in Ethereum that kind of allows for anyone to use it, not only encumbered addresses, then you want to be able to use it with encumbered address without using this kind of encumbrance property. Because once you lose it, you kind of have to gain it back and send it to a new address. As we said before, once the private key is unencumbered, you kind of lose this encumbrance property, so you have to regenerate a new private key or kind of reprove to Oasis that those keys, those funds still are in the encumbered account. So we are looking how can this interaction between encumbered accounts and non-encumbered accounts happen. That would enable encumbered accounts to interact with smart contracts in Ethereum. And the end goal would be, of course, as you mentioned, be able to stake Bitcoin tokens in the Aave in Ethereum.
Or Uniswap and Uniswap, or take out a perpetuals. Yeah, it's very cool. So my next question is, you mentioned that it's bridgeless. How exactly is it bridgeless? Because at some point you still need to be able to see what's happening on Bitcoin or see what's happening on these other networks that are outside Oasis, right? So what's like sort of your vision right now for how that communication happens, and how is that different from how bridges communicate?
Yeah. So the basic idea on why you don't need bridges is that you can have Oasis know what happens in the other chains by kind of forcing the behavior itself. What I say when I say that is that the bridges are basically a way for Oasis chain to know what's happening in Bitcoin. But when it comes to encumbered accounts, all the signatures that come from the private key have to come from Oasis. So Oasis actually knows what messages or like the network has signed and what messages it has not signed. So by ensuring that the messages it signs end up in the other chain, then it can kind of trust that the messages are in the other chain and don't need any bridging to kind of confirm that those messages have been deposited or that will be deposited at some point.
You don't have to wait for finality or something, like I know that Bitcoin has 5 block finality or roughly around there. You don't have to wait for that.
Yeah, finality is actually the biggest threshold when it comes to cross-chain interoperability. And our construction, since it does not use bridges, it does not need to wait for finality. How it does that is when the address is encumbered, the account is encumbered, you can use the key to get signatures from it. The main difference with this cross-chain interaction, we create what we call the commitment policy, which when you request a signature with a specific nonce, for example, you commit to that transaction, meaning that the encumbered account will only sign that specific transaction with that specific nonce. And while the encumbered account cannot know, because it has no bridges, when that transaction will be deposited, it knows that it's the only transaction where you can deposit with that account. So if you want to do more things with that address, for instance, I want to send you some Bitcoin, I want to send someone else some Bitcoin, it will ensure that before I send someone else some Bitcoin, I will have already sent you some Bitcoin, because you can only chain transactions if you have done the previous ones.
Okay, so what happens if the previous one was not done though? Is that a possibility where like the no transaction occurs, and does that break any of the trust assumptions?
Yeah, that's also a problem we face. For instance, if I kind of sign a message to send you some Bitcoin, sign a message to send someone else some Bitcoin, but I never sent it, it kind of breaks this breachless assumption that we made. The thing is that once you commit to a transaction, you can allow anyone to get that signature, because as long as I committed to it, then anyone can submit the transaction on the other chain. So if I'm the one sending the Bitcoin, I will commit to sending you some Bitcoin. Then you, for instance, will be able to get the signature of that transaction, sending yourself some Bitcoin from my account and deposit it on chain. That kind of removes the need of for the person that actually can commit to the transactions to be the one that has to submit the transactions.
That's very interesting. So it's, I guess, similar-ish to an optimistic model where it's like, all you need is one good actor in order to make sure that things are done. That's cool. I didn't actually realize that's how it's working. Okay. I guess, yeah. So like right now you're working on just like the cross-chain, basic implementation where you're having, a wrapped Bitcoin. Maybe you can interact with some smart contracts there. But you also mentioned that like the next step of the research is to add smart contract functionality on top of these networks. One, like, I guess I have a ton of questions about this too. But yeah, what does that mean to add smart contract functionality? Does that mean that it can interact with Ethereum, like in terms of Aave, like we talked about earlier? Or does that mean that you could even create, like, let's say, a Bitcoin swap or atomic swap with any network? Like, what are some of the use cases you see when you say that you can add smart contract functionality?
Yeah. So once the assets are encumbered or are held by an encumbered account, Oasis knows what's happening in the other chain, and therefore it can allow, for example, to do atomic swaps between Ethereum and Oasis within the between Ethereum and Bitcoin within the Oasis chain. This is done by implementing a smart contract in Oasis that only allows interaction from encumbered assets. And then if you do an exchange of wrapped Bitcoin with wrapped Ether, you're actually doing the exchange with real Ether and real Bitcoin on their respective chains. That's the cool thing about encumbrance, that no matter if it's wrapped, it's actually jumping from address to address in the respective chain.
Right, that makes sense. So that's I guess where you get this idea of it's not necessarily bridging so much as it is bridgeless cross-chain communication is really what you guys are working on. Yeah, I mean, I know it's going to be a while. I know that, research takes, has to be done thoroughly and securely. But I can't wait until you guys, get further along with this and we can start building out some of these things. I guess my last question in regards to this is like, we've talked a lot about Bitcoin. Are you thinking about any other networks that might make sense to include in this? And, if so, why those networks?
Yeah, the first network, I actually worked with Ripple quite a lot last year during my time in Berkeley. So they were looking into how to add this kind of smart contract functionality, or even they were just looking for basic functionality such as ZK bridges or trust bridges. So when I came to Cornell and I started working on that project, I saw it was actually a really nice trustless construction of a ZK bridge that could work on top of blockchains that don't have smart contracts. So I would be pretty excited if XRP actually implements some kind of smart contract overlay on top of their network. That I have a pretty close contact with them, and they are really nice. And but yeah, I feel any chain that once, I feel like encumbrance is going to be a big thing sometime in the future. So if you want to have native like atomic swap interactions with any chain trustlessly, then you will have to kind of adapt this new landscape of encumbrance.
I like to hear that. Encumbrance will be a big thing in the future. That I think that carries weight coming from Ori, who found proof of work, and then Philip Dion, who is now the head of Flashbots. I think we've seen that this lab definitely can change the landscape of Web3. And for Oasis's sake, I hope that the liquefaction is the same. Cool. So I guess that's like basically it in terms of liquefaction. I know is a lot of technical detail. Hopefully not too hard for you, the community to follow. But now I just wanted to maybe go into some more questions just in general about like you yourself, and what are you doing this summer outside of work, and what maybe some of your hobbies or other areas of interests.
Yeah, I'm actually here. I usually do the PhD in New York. That's where Ari's team is based, in Cornell Tech. But my partner is actually finishing her LLM here in London. So I came to work remotely for the summer here in London. And I've been learning to row. That's been super fun. I've been getting to know London quite a lot. It's a sunny day today, which is always a good thing here. And yeah, I really like kind of getting to know the city from kind of more not a tourist perspective, from a local perspective.
Yeah, it's very different than New York City, right? Unfortunately, we're not going to be able to see you at IC3 Day. Me and a few colleagues will be in New York there, but hopefully we'll be able to catch up at a conference sometime soon. I guess any other closing remarks? Anything you want to say in terms of where people can follow your future research or follow the other research that's coming out of the lab from James or from Ari? Just any like last minute sort of closing remarks?
Yeah, we publish all our research. If you want to kind of stay up with the group, our group is part of the IC3 lab. It's kind of a cross college lab that has people from different universities, and it posts every paper we publish on LinkedIn and Twitter. As well as if you follow Ari Jules, he will publish everything we do quite frequently there. And all the papers have links to the GitHub repos with all the work if you all want to kind of work on top liquefaction or our implementation. Take My Ape demo is out live in takemyape.com for anyone to use. You just need less than $1 worth of ETH and just a few cents of ROS, and you can interact with the demo. And yeah, I'm pretty excited. I hope people kind of follow up our research. We are kind of doing some cool stuff now.
Yeah, absolutely. And it's there's, like you said, you mentioned like 15 use cases in your paper. I think we talked about, two of them today. That would be the NFT rental one, which is what Take My Ape is, and, the cross-chain stuff. So there's another, 13 use cases if someone wants to build a business or, create a cool application idea. So if that is the case, reach out to me or reach out to Danny, and we can, help you get started on your idea. Or if you're a researcher, I guess, find a way to reach out to Danny or myself, and we can maybe collaborate on some future projects. Besides that, follow Oasis on Discord, on Twitter, on follow our blog. I forget what I think it's oasis.net is the new website name. And then besides that, we are actually going to be at ETH Belgrade next week, as well as ETHCC at the end of June. So if anyone is attending either one of those conferences, definitely come say hi. But yeah, thanks everyone for joining today. We look to, hopefully it was insightful and you guys learned a little bit more about Liquefaction. And we hope to see you all at the next ecosystem spotlight. Bye-bye.
Yep. Thank you. Bye.